Hi all, welcome to the KT. Today we are discussing about the network core. It is a topic in the first unit in the computer network subject. What is network core? Definition. The network core is a central part of a computer network that consists of a mesh of interconnected routers and the high-speed links, forming the backbone of the internet. Uh, I will go with an example, then it will clearly understands for you. Here it is an example. System A and system B. If the system A wants to send data to the system B, these routers and the switches we want to send the data. In definition itself, it says that central part of a computer network. It is a central part. We have system A and system B, but without this central part, the system A doesn't send any data to the system B. So it is a central part that consists of the mesh of interconnected routers. Mesh of interconnected routers. R1 is connected to the R2, R3 is connected to the R4. If you want, there will be another router like this. It will be connected like this. It will be connected like this, or it will be connected to the like this. Like because in a router there will be a lot of ports. There will be a lot of ports. It will connect to the any devices. So and high speed links, these are all the links. Here arrow marks are there, right? These are all the links that by these links only the data will be forwarded one node to the another node. Next we are moving forward. It connects many edges, networks, and the end systems, and its main job is to move packets from source to destination across multiple routers. The network core, its main job is to forward the packet from source to the destination through the multiple routers and the switches. Through the multiple routers and the switches. Core versus edge end systems and access networks, PCs, mobiles, wi-fi's, etc. End systems like I said in before example, system A and system B. These two systems are the edges, pieces and the mobiles, etc. examples. And core, high speed routers and the links that carry traffic between these edges. Like between we have the R1, R2 and R3, R4 and the switch. These are all the core and the links between the routers and the switches and the system A and R1. These links are also a main part in the core. Switching in the network core. Switching in the network core. The internet core mainly uses packet switching. Messages are divided into small packets, and each packet is forwarded router to router using store and forward transmission. Like I will take an same example, it will be clearly understands for you. Here we have, right, example. System A and system B. System A sends a message, "Hi Ram." Here, "Hi Ram" will be divided into the packets. Like it will based upon the text, it will divide the packet. Here the text is only simple to "Hi Ram." There, right? It may be divided into two or three or four, maximum of 3 to 4 packets. That data will be sent to the R1 and R2 and R3 and switch and to the B. Most of the cases, what it said means the intercore mainly uses the packet switching. The data which is divided into small units. That is called the packet switching. The data, like for example, here IRAM is there. This IRAM will be divided as H in one packet, I in one packet, in another I in packet, or else in total RAM in one packet. The data will be divided into packet 1, packet 2, 3 and 4. Like this, the data will be divided into the packets, and each packet is forwarded router to the router using store and forward transmission. Like this, the data will be forwarded from one router to the another router, R1 to R2 and R2 to switch and switch to the B. Here store and forward, it is said that like whenever A is sent to the R1, like high H will be stored here, and then it will store and then it will send to the R2, and then it will store to the switch 2. Here R2 is the last node to the between the A and B, because R2 will store the data and it will wait until all the data is received here, and then it will send to the system B. That is called the store and forward the packets. You may got some doubts these routers, how the data will be transferred from one system to the one node to the another node. There will be a routing table in every router. Based upon that routing table, it will send to the source to the destination. What is the key features and the properties from this? It uses the statistical multiplexing, which means users can share the same link efficiently. Like users can uses the same link. Like for example, system A is there, another system B is there here. It also uses the router one, and it can use the same link here. Here data comes from R1, from A to R1, B to R1, and then this link is common for the A and B. So these links are reusable for any users. It is built to be very fast, able to grow easily and stay reliable. If one link or router stops working, there are extra paths to keep the data moving. For example, here we have the router A sends the hi message to the system A sends the hi message to the R1. Here R1 is failed. R1 is failed. Then it will choose the R5 directly R5, and it will change to the switch 1 and it will change. If this R5 also failed, it will choose the R3 and R3 to the 4, 3 to the switch 1, and it will goes to the B. Same like this. They stay reliable. Reliable means the data without missing any packets, it will reach us to the destination. If one link or router stops working, there are extra paths to keep the data moving. It is the last point in our topic. Main functions in the core: routing, choosing an end-to-end path throughout the multiple routers for each destination network. Like just now I have explained that R1 fails, it will chooses to the R2, R2 fails R3. Like this, choosing an route, in name itself routing is there, right? Routing means choosing an path from source to the destination. Forwarding and the buffering, moving packets to correct outgoing link, temporarily storing them in queues when links are busy, and dropping them if the buffers overflow during the congestion. Moving packets to the correct outgoing link and temporarily storing them in queues. Are a router system here sends the message to the router 1 and router 1 to router 2, router 2 to switch 1 and switch to the B. Like here what it says, temporarily storing them in the queues. R1 stores the temporarily for some time, and then it will send to the R2. And here sometimes it will be stores because of some other packets will be missed, and again this R2 will send some message to the system A, and again system A sends the message to the R2. Here all will come here, and all the messages will be reassembled here, and directly it will send to the switch one will send to the B, like this, storing them in queues, and which when links are busy, R1 is busy, it will goes to the R2, and dropping them if the buffer overflows during the congestion. If the R2, here switch 1 is there, right? Switch 1 will have the data receiving power. Data receiving power is low. Then R1 sends the packet um, again and again. It will send the packet sequentially order, but switch 1 is not receiving. Then switch 1 will misses the data here. The packet loss will be happen here. So this is the happens. This is the last point in this. Thank you for watching. Please share, like, and do comment. Comment will be feedback for me to improve my video quality and explanation, and whatever drawbacks in me, I will try to overcome all the drawbacks in the next video. Please do comment in the comment section.